How to create this kind of mesh for this Girder column connection using Bentley SACS Joint Mesher. Hello everyone, my name is Rafael Lara and I'm a structural engineer specialist in offshore structures analysis and design. One of my duties in Bentley is to help our users succeed in their offshore structural projects when using either Bentley SACS or Open Wind Power Fixed Foundation. In this video, I will present all the necessary steps for you to easily create this mesh that you can later use for structural analysis and design of your structure in installation and operation conditions. You can also extract stress concentration factors for fatigue analysis using this tool. And before getting into the topic, I would like to thank you all for the audience. And for those who are new in our channel, you may want to push the subscribe button so you receive in first hand all of our updates. Let's do a quick overview of this joint. It's a commonly used in the topside models of offshore structures. Here we have a column, a tubular column, which is our core, and we have connected to it 4 beams with a plate girder cross sections, which are our braces. And we have these rounded parts here created with plates, and they have the same flange thicknesses. And the dimensions of there then can be verified in the properties in member section. And if we select this one, which is related to the plate girders, they're going to be in red. If you click at it, you're going to see the dimensions of the plate girder. And let's take a note of this height, 100 centimeters, and the flange thicknesses, which is 4 centimeters. We're going to use this later. Okay. I should also say that this is a simplified model. There's no global stiffnesses or loadings in here. I would just want to focus on generating the mesh, and to take it into account the stiffness and the loadings, you may either use springs representing the stiffness and applying the loads, or you can just use your global model. Right? Let's close this and open up our model from the beginning. This is our model with no mesh, just the beams. And the first thing we want to do is to go to the Joint tab and then push the Joint Mesher button to access the GUI of the Joint Mesher program. And here the program is going to ask us for the joint name or the mesh input file. We're going to start from the joint name. We're going to use this joint. You can just type it or select the joint. And let's hit OK. And now we're going to have a new window right here. We had the active structure window, which is the one that we were working. And now we have this new one, which is the one that we're going to use the Joint Mesher GUI. And on the left-hand side, we have the joint that we're going to mesh and the members, the cords and braces. And on the right-hand side, we have the instructor. It's going to tell you some instructions to work with the Joint Mesher. And Up here, we have this window, which is the Meshed Joint Properties window. And here's where you can control your mesh. Okay? And let's start here defining our mesh parameters. The first one is the mesh intensity. And here we can use high numbers for finer mesh and low numbers for coarse mesh. Okay, let's use 2 for this sample. And also we have the brace intersection subdivision. This is related to the intersection between the braces and chords. And what this command does is to subdivide your mesh at the intersection. And if we use 1, we're going to have a uniform mesh. The 2 next ones is the target length, and they are used to override the default length of the mesh along the member. We're going to use the default, right? So nothing, don't need to change anything here. And the last one is the mesh type. The mesh type, we have tris and we have quads. We're going to use quads. And a quick note for this, here we are selecting only the mesh type. This is not related to the element. If we're looking for the element, we should do something else. There is no option in the Joint Mesher GUI to define the element. Actually, every time we select something here between tris or quads, it's associating it to plate element, which is the default. We can change it later. We're gonna do this later in this video, and let's just leave as quads for now and go ahead. All right. The next step, we need to define the surface that is going to be meshed. And the first thing we're gonna do is to add a plane, just like the instructor is telling us to do. Let's click the Add Plane button. And we have some lines here, but this is at the center line of the beams. We don't want to be here. We have to move this plane to the top or the bottom to create our surface. And let's start from the top. I'm gonna rename this as top. And the plane is the X and Y. And here we're gonna move this plane to the center line of the flange, which is at 48 centimeters. Right now we can see the lines representing the flange. And here we're gonna add a surface, a plate surface. And this plate surface, we're gonna rename it at T left. We're gonna use quads, and the thickness of the plates here is 4 centimeters. Okay. And let's start creating our plate surface. Let's click at the arc transition. Click this line and this line. And now I'm gonna click right here, and it's gonna ask for a radius. For this sample, we're gonna use 1 meter radius. And here we're gonna have this arc in red, which is connecting this flange to this flange. I could do another one here, another one here, another one here, but there is a problem with that. Joint Mesher works with closed regions. So if we close something like this, we're gonna have a mesh inside this tubular cross section, which is not correct. So to avoid this, we're gonna click the line tool, and then gonna go down, and let's create an arc tool. It's gonna ask for the center point. Let's start the arc from here and finish here. And to find the point that we want here, we can just create an auxiliary circle. And let's put another line here. And then we can, let's delete this circle by selecting it and then hitting the delete button at your keyboard. All right. Now we can create another arc transition here. Let's select this line, and click here, and 1 meter. All right. And we're gonna close this region like this. So we have a surface plate at the left side. That's why we are calling it T left, top left. And now we're gonna create another one at the right hand side. And let's start from here. Actually, I have to create a plate surface. Let's give it a name as top right. Gonna use quads. And I'm gonna use 4 centimeters for thickness. Hit apply. And now it's activated. Let's start creating our line. Put an arc transition here. Another line. Another arc transition. Note that I'm following the sequence. Okay, try doing that to avoid any issues with the joint mesher. And let's connect it here. And here we're gonna have duplicated lines because this line belongs to the left. We have to create another that belongs to the right. Arc 2 again. Let's start the arc from here to here. And let's create another line to close this region. All right. Now we have these 2 regions that are 2 different plate surface. And now we have to create the one that is in the bottom. And for that, gonna add another plane. We're gonna call this as bottom. And the offset here is minus 48. I'm not gonna do everything again. We can easily create the plate surfaces by copying from the top and pasting at the bottom. Just need to give another name. I'm gonna call B left. Let's copy the right. And let's call it B right. Okay, now I have both planes, bottom and top. And the next step is to save our mesh input file. Yes, it does create a mesh input file. Let's use this option here. I'm gonna use this name. Don't need to change anything here unless you wanna give it a different name. And let's go now to SACS Executive, and here it is, our Joint Mesher input file. Let's open up this with a data gen. Okay, remember that I said that we work with plates and shells, but there was no option in the Joint Mesher GUI to change between them. Here we can do that. There is an option here on the mesh type, and if you click on the arrow, you're gonna see tri plates, tri shells, and quad shells. We're gonna leave as plates for this sample, but you can use shell elements by changing it. You also may change here in every P name line. Hey, this is release 2023. Maybe for the next release, make a change and there will be an option in the Joint Mesher GUI. But so far, we have to do this manually in DataGen. Okay, so let me close this and go back to our file. Okay, let me show another thing here. I'm gonna close this and let's go back to our starting point and go to the Joint tab, the Joint Mesher button, and it's gonna ask for the joint name. Now we're gonna use our joint mesh input file that we just created. Click OK, and here it is. We have our plate surfaces again. All the definitions were read. And the next thing we want to do is to create our mesh. Go to the mesh joint button and click on it, and I'm gonna see this listing file, and here we have all the information about the joint and how many nodes and elements were created, and in the end we're gonna see this message telling us that the joint was meshed successfully. And then we can close this and take a look at the mesh. Is our mesh. So mainly you can see quads, but also there are some tris here. Need to check if it's acceptable or not. You may want to refine the mesh to get a better mesh if it's the case. We also want to take a look from the top, see if there is no plates created inside the tube. There is nothing here, and it's done. Our finite element mesh has been created. That's all for now. And in our next video, we'll learn how to extract the SCFs from the mesh that we just created. Thank you all for watching. And if you like this video, please give it a like. And we also would appreciate your comments and suggestions. And don't forget subscribing to get more updates and content like this. And see you all later.
Thanks for watching. If you found this video helpful, please give it a like and share it with others. If you want to see more like it, please consider subscribing to this and Bentley's other channels. Thank you, and see you next time.